Hello everyone, today we are solving LeetCode problem number 2706. Buy two chocolates. In this problem, we are given an prices array representing the prices of various chocolates in a store, and you are given a single integer money, which represents your initial amount of money, and you must exactly buy two chocolates in such a way that you still have some non-negative leftover money, and you would like to minimize the sum of prices of two chocolates you buy. Okay, and what we have to return is amount of money you will have left over after buying two chocolates. And if there is no way to buy two chocolates without ending up in debt, return just money. Okay, so in this problem statement, what is given to us is like we have prices array, which are the prices of various chocolates in the store, and we have initial money, and we have to choose two chocolates, let's say A and B, such that the price of two chocolates, let's say A is at ith index, B is at jth index, the price of two chocolates is minimized. Okay, and we exactly have to choose two chocolates, not more than or less than. So if we are able to achieve this using our money, in that case, we will just return the leftover money. Otherwise, return the money if we are not able to buy any two chocolates. Okay, so let's say in this case, 1, 2, 2. We have money as 3. So we'll be choosing the least prices chocolates, like any two chocolates which are having least prices. So maybe the least price or the second least price. So for that, first of all, we are going to choose 1, and after that we are going to choose 2. So we are using 3 unit of money, and we were having 3 in the as the initial money. So we are going to return 0. 3 minus 1 plus 2, which is 0. Okay, so how do we approach this problem? Let's also have one more example. Let's say 3, 2, 5, and we have money as 1. In that case, we have to choose two chocolates, exactly two chocolates. So if we choose the minimum amount 2 or 3, that is also more than the money we have. In that case, we cannot buy any two chocolates. In this case, we are just going to return the money. Okay, so these are two AND cases. So how do we approach that? So first of all, what we can do is we have to get a pair. Let's say I index and J index from our money from our prices array, such that the price of two item is minimum. Are we going to check all the pairs in this array, like going n square? Do we really need that? No, I don't think so, because we only need a pair which is having minimum value. Let's say smallest and the second smallest value. So if we are going to do n square, that is checking every pair, that is not going to make any sense. So this n square solution is useless. Let me jump to the second approach, which is like sorting the array, because we only need the smallest and the second smallest element. So if we sort the array, at the 0 index we will have the smallest element, at the 1 index we are going to have second smallest index. So we can just take sum of these two elements. This will be the amount of money we are going to use. Okay, if we sort this array, we are going to use n log n time, and the space complexity is the only space we are using for our sorting algorithm. In our program, we are not using any space. So if we do n log n, we are able to achieve our solution. But let me ask you a question. You are given an array 1, 2, 2, and you have to find the smallest element among in this array. So how do you do that? We don't generally sort that, we just do the single iteration over this array. So by checking the smallest and the second smallest element, we can also achieve these two items in a single iteration. We will take two variables, smallest and the second smallest, and we will keep on updating these variables while doing the iteration over the array. So if we are able to achieve that in a single pass, So that is going to be O of n time, which is significantly higher than the n square which we started and n log n which we discussed in the second approach. So this third approach, like doing a single iteration over array and capturing smallest and second smallest element, is making the sense, like giving us the most time efficient solution. Okay, so once we have the smallest and second smallest element, we can check the sum of these two elements with money. In that case, we are directly going to return money. Otherwise, we will return money minus the least two sum. Okay, let's now code this third approach in which we are doing a single pass over this array. First of all, we have to take two variables, smallest and the second smallest, and initializing it with the maximum value. Integer dot max value, integer dot max value. Now we will iterate over this array int p prices. Okay, so if this price is less than the smallest element, it means we will update the smallest to the second smallest, and smallest will be updated to this. Else if p is less than the second smallest, not less than the smallest, it means we will just update the second smallest. Now after this iteration, we have smallest and second smallest updated. Now we'll check if smallest plus second smallest is greater than the money. If this is the case, we are going to return money from our problem. Otherwise, we are just going to return money minus sum plus second smallest. Let's test our sample test cases. SS. Here we have to use comma, not semicolon. Submitted successfully over sample test cases. Submitting the problem. Beats 100% of the Java users. Okay, hope you understood the problem. Thank you guys.